themselves something new, as well as help each other learn. Whether it's from art classes or lunch and learn talks on latest technologies, there's always something new to find and help yourself grow. And I really feel like that's one of the best things that any company can offer is growth and opportunity.
Hello, everyone, and welcome to Denver Startup Week. I'm Connor Swanson, the Developer Track Chair and member of the Denver Startup Week Organizing Committee. Thank you for joining us for our first ever Denver Startup Week virtual. In 2020, if 2020 has taught us anything, it's that we are more powerful when we come together as a community to share ideas and help make each other better. And here we are virtually showing the world what Denver is made of. At Denver Startup Week, we strive to make all of our sessions a space where attendees can connect, learn, and grow, regardless of gender identity, gender expression, race, ability, sexual orientation, and the combination of those identities. There's something for everyone at DSW. Thank you for joining us. With that, I want to reiterate my thanks to all of our Denver Startup Week sponsors, and specifically Quizlet, our Developer Track sponsor, for helping make this week possible. Thank you. I'd now like to introduce you to Katie Scruggs, who will be leading this awesome session.
Hi, everyone. Nice to see you all here virtually. My name is Katie Scruggs, and the talk today was pre-recorded to make sure that everything went smoothly in this virtual format. But before we kick it off, I would just like to invite you all to introduce yourself, if you'd like, in the chat, and say what your familiarity is with GraphQL or what brings you to this talk today. You can select to either send this to all panelists, but it would be great to send it to all panelists and attendees so that everyone can see who else is here and make it feel like we're all in the same room together. And with that, we can go ahead and start the pre-recording. Thank you. Hi, everyone. I'm Katie Scruggs, and I'm really excited to be bringing you a virtual presentation today for Denver Startup Week about GraphQL and my journey to GraphQL and back again, a Hobbit's tale. Before we dive in, my name is Katie. I'm a software engineer at Handshake, and Handshake is a company whose mission is to help students get their first jobs and internships out of university. You can check us out at joinhandshake.com if you'd like to learn more. I'm on Twitter at KatieE.Scruggs, and if you'd like to post anything with the hashtag DenStartupWeek, feel free to post any questions even after the talk is over, and I'll be happy to answer anything. Also, just want to take a moment to say thank you to Denver Startup Week and all of the sponsors for putting this on virtually. I'm really excited that we still get the opportunity to do this year. Okay, so what is GraphQL? GraphQL stands for Graph Query Language, and the docs of GraphQL actually do a great job of explaining what it is. So I'd like to take a moment and just look at those with you all for a second. So as I just mentioned, it's a query language for your API. And over here on the left side of the screen, you can see that what it allows you to do is ask for specific objects and fields from a database and get back exactly what you ask for. So one of the really cool things about GraphQL is that if you only need a certain subset of data, on the front end, you can ask for that, and the back end will return to you only that subset, so there's no overfetching. You can also get a lot of resources in a single request, even nested resources. So this is really handy. Instead of having to make a request, get back a hero, Luke Skywalker, and then make another request to get the friends of that hero, you can ask for that all in one go and get everything you need to load the page in one single network request. Now, this does have some downsides that we'll come back to, but it's super flexible and really cool that you can ask for as much data as you want and get that back. GraphQL also helps you describe these objects and fields with a type system. So it's kind of a cool way of thinking about things where you're thinking about these entities or objects and the data that they have attached to them so that you can ask for those entities, get back exactly what you need, instead of having to worry about what endpoint am I hitting, should this be a post, a patch, a put. It's all in this query language. What do you need to do, and get it back. GraphQL has two kinds of requests. Queries, which if we're talking about our CRUD API actions, are reads, getting information back from a database usually, or from another external API. Mutations are when you're updating something and changing something in the database. So that would be creates, updates, and deletes. And for the purpose of this presentation, I have put together a super simple implementation of GraphQL with the Node API. This is the entire server file, so it's really short, really quick to get up and running. I did put this up on GitHub if you want to check it out. There's a link here. You can pull it down, mess around with these endpoints or the docs if you want to. But all we had to do was import Express, which we would do for any Node API, import Express GraphQL and GraphQL. And then you'll see right here where I'm saying const schema equals build schema. Here's where I'm defining what you can do with GraphQL. So I'm saying, hey, for type query, we're going to have two types of queries. Hello, which should return a string, and error, which should return a string. Spoiler alert, it's going to throw an error for the purposes of demonstration. It's not going to return anything. And then I also have a mutation type called setMessage, which takes in a single parameter of message, which is a string, and returns a string. Then down below, we see const root equals, and here's where these functions will actually be invoked when we make these queries to GraphQL. So hello will return the string world, error will throw an error called example error, and setMessage just takes in that message parameter and returns it to you. Again, this is super simple, and normally with these queries, we would be hitting a database and then returning our result. With the mutation, same thing, we would be posting or updating something in the database and then returning the result. And then with this Express GraphQL npm package, it's as simple as saying app.use/GraphQL, passing in GraphQL HTTP.
Hey guys, sorry about that. I'm going to try to get us back to where we were.
Hi, everyone. Okay, so now that we know a little bit about what GraphQL is, I want to tell you about the use case that I was using GraphQL for. And this actually wasn't at Handshake, it was at a company I was at previously. But we were building an API for a new internal tool with around 250 users, so not a super high user count. Other teams would also be using this API. We needed basic CRUD functionality, create, read, update, and delete. And we didn't know exactly what endpoints we would need. And so GraphQL is super helpful for that. Instead of having to design an entire RESTful API, thinking about all of the gets, all of the puts that you would need to make something work, you can just set up GraphQL and these types, these queries that allow you to access objects in your database, and then work with that and expand it really simply. Okay, so we'll go ahead and get into now why we decided to sunset GraphQL. So GraphQL, obviously it's super cool, and it was working pretty well for us, but we ran into some major drawbacks along the way. The first and most important was that other teams didn't know how to consume it. We also had some interesting issues with how GraphQL handles errors, which I'll show you, difficulty diagnosing latency issues, and a general lack of convention around GraphQL, probably because it's a newer technology, both in the industry at large and within the company, especially around mutations, so we'll get to that as well. Okay, so the first problem was that other teams were not aware of how to use our GraphQL API. So normally when a team reaches out and all they want to do is use this API for some pretty basic things, we want to create some objects in this database, you might expect to get something like Swagger Docs. So some of you have probably used Swagger Docs in the past, but I'll show you an example here. This is just from swagger.io, an example pet store API that they have. But this is super RESTful convention of Swagger. And Swagger is a really cool tool if you haven't used it. There are integrations you can do too, where if you update an endpoint, it automatically updates the docs so they never get out of sync. But if you're like, okay, what do I want to do? I want to add something to the database. I want to add a pet to this pet store. Then you can see that these docs are really explicit and very clearly defined. So like very set in convention, kind of rigid, not very flexible. But if you know what you want to do and you see, okay, this post/pet will add a new pet to the store, it's really simple to find that, see what kind of request body you need to send in, try it out in the browser, maybe try it out in Postman, and continue on. In contrast, GraphQL has docs that look something like this. So as you can see, And by the way, GraphQL is a super cool tool, but almost a little bit intimidating, like a blank page, right? So you don't see all these separate requests and can see, okay, here's how I get something, here's how I add something to the database. Instead, it says, welcome to GraphQL. It's an in-browser tool for writing, validating, and testing GraphQL queries. Type queries into this side of the screen, and you will see intelligent type aheads aware of the current GraphQL type schema and live syntax and validation errors highlighted within the text. And there is this documentation explorer over to the right side of the screen. What we ran into a little bit was that it's pretty easy to forget or not notice that this is there, so you do have to expand it. But then you're able to see, okay, if I want to make a query, what kind of queries can I make within this setup? And you can see the two queries that I showed you, hello and error. And we also have a mutation, which is our set message mutation. So there are these docs here. And in order to test this out, instead of clicking the Swagger try it out in the browser, what you can do is down here, start typing a query. And it tells you here, make sure you start with a curly brace. And if I start typing hello, it does have that intelligent type ahead, so I can click enter. And then if I press command enter, it'll run this query and show me the result here in this middle pane. So really cool. You can see that the result here is always going to be nested under data, and then nested under hello, which is the name of the query, and then the result, which is world. Mutations look a little bit different, so I'll show you what that looks like as well. You have to say mutation, open curly braces. And then it was set message, and we can look at the docs while we do this too. Set message, message is Denver Startup Week, and then command enter, and you can see that it returns that string for me. So pretty cool. But you can imagine that if you're a developer who's super used to RESTful conventions, super used to getting these specific endpoints in Swagger docs or something similar, and then you get sent this graphical interface, you might be a little bit intimidated at first, and it takes a little bit of getting used to. Something else that comes with this format of a query is that queries can get a little bit complicated. So I just showed you some really simple examples that I had, but especially for something like a paginated query, you can see here that there's edges, node, ID, title, description belonging to the records that will actually come back, total count, you can get page info as well. And it's really simple to misform this query and then get a kind of frustrating error that looks something like this. Syntax error, expected name, found, EOF, and not know exactly how to get back from that. Especially in Postman, so I'll go ahead and show you that you can easily make these requests in Postman as well. And what you have to do is just put in as a query param the query that you want. So we'll use our hello query and click send. But again, if you're trying to put in a paginated query, it's not very intuitive to try to keep typing all these curly braces and formatting things properly. So GraphQL is really easier to use in my opinion, but you may not know exactly how to use it and be familiar. So speaking of strange errors that you can get, let's talk about error handling. So these are our HTTP status codes. 200 means successful, okay response. Level 400 means user bad request. Level 500 means server error of some kind. And let me show you how GraphQL handles errors. So let me get rid of our mutation and go back to our hello query. And I'll open up the network tab so we can see the request actually happening as well. So when I make this hello request, you can see that I get back a 200 okay response, which makes perfect sense. If I misformat or try to query for something that isn't there, then I don't get a 200 anymore. Instead, I get a 400 bad request, which makes sense. If the query is not properly formatted or you're trying to get something that's not there, user error, right? The interesting part comes when an error occurs in the resolve functions that are being called when you're trying to query for something. So let me quickly remind us. This error query just throws a new error. That's all it does. So let's see what we get. Okay, so we see that we get this response in this middle pane that says errors, message, example error, which is what I threw. We also get back data, error, null, but the request that comes back is a 200 response. So that means the response was successful, but we're also getting errors. And this is totally intentional because what GraphQL is doing for us is saying, hey, you can get back data and errors in the same request. You can ask for as much data as you want, get back partial success, do something with that data, and also get back errors and handle those appropriately. Unfortunately, for the use case I was working in, we never found a reason to get partial data back or do something with partial data and also have errors.
The video
So
is a
instead,
little
what we
blurry.
do is every 200
could
successful
try to pause
responses, check to see, does response dot errors exist? If it does, then treat it as though there was a 500 error and reject a promise or throw a new error and pass that up the chain. So it wasn't the end of the world having to do that, but again, with different teams and teams that make
pausing one more
get
time.
back.
And I can go ahead and share my screen and I can play the video from there and see if it's better for people.
That sounds good.
Okay.
Yeah, I'll go ahead and stop share.
Would you
Yep.
mind telling me what minute we were at?
We were. Yeah. We were at 1304.
1304, awesome. Would
Yeah.
people, if you don't mind posting in the chat, if you'd like me to go back a little bit further, if it was blurry before, we can start with the error handling slide, or I can start at 13. Yeah, it was ready from here on out. Okay, awesome. I'll start it right here, and then I will put myself back on mute. Let me know if you can hear the audio. Speaking of strange errors that you can get, let's talk about error handling.
That you can get. Let's talk about error handling. So these are our HTTP status codes. 200 means successful, okay response. Level 400 means user bad request. Level 500 means server error of some kind. And let me show you how GraphQL handles errors. So let me get rid of our mutation and go back to our hello query. And I'll open up the network tab so we can see the request actually happening as well. So when I make this hello request, you can see that I get back a 200 okay response, which makes perfect sense. If I misformat or try to query for something that isn't there, then I don't get a 200 anymore. Instead, I get a 400 bad request, which makes sense. If the query is not properly formatted or you're trying to get something that's not there, user error, right? The interesting part comes when an error occurs in the resolve functions that are being called when you're trying to query for something. So let me quickly remind us. This error query just throws a new error. That's all it does. So let's see what we get. Okay, so we see that we get this response in this middle pane that says errors, message, example error, which is what I threw. We also get back data, error, null, but the request that comes back is a 200 response. So that means the response was successful, but we're also getting errors. And this is totally intentional because what GraphQL is doing for us is saying, hey, you can get back data and errors in the same request. You can ask for as much data as you want, get back partial success, do something with that data, and also get back errors and handle those appropriately. Unfortunately, for the use case I was working in, we never found a reason to get partial data back or do something with partial data and also have errors. So instead, what we had to do is for every 200 successful response that came back, check to see, does response.errors exist? If it does, then treat it as though there was a 500 error and reject a promise or throw a new error and pass that up the chain. So it wasn't the end of the world having to do that, but again, with different teams and teams that may expect to get back errors instead of a 200 response with an object that includes errors, it was another thing that wasn't quite what would be expected, and so there was a communication issue there. Great. Next up, diagnosing latency issues. So before we get into latency issues, I found these great diagrams from Jeff Lombard Jr. So total credit to this Medium article, When and Why to Use GraphQL. Recommend you check it out if you have the time. But this is a diagram of what a RESTful architecture would look like. You have different requests, post, delete, get, put. You have different endpoints that those hit. And then you have handler functions. So everything is very defined and very linear. One endpoint to one handler function. With GraphQL, you have this request object that can be formatted in any way that you want. It all hits one single endpoint / GraphQL, and then there are handler functions that take care of things based on how that request object is formatted. And this is really cool, just want to point that out before I progress, because it abstracts away a lot of what you have to worry about with a RESTful structure. You don't have to worry about what kind of request should this be, what exactly am I doing? Instead, you can just say, this is the information I want. I'm going to hit this one endpoint, and I'm going to get back what I need. However, this led to some problems with trying to diagnose latency issues. So this is a screenshot from a tool called New Relic, and it allows you to look at how slow your endpoints are going and actually really drill in and see, how, like for a specific endpoint, what is taking so long? Is it the database query that's too long? Is it something else? Datadog has a really similar offering called Datadog APM, or Application Performance Monitoring, if you have a chance to check that out. But really cool tool, allows you to dive into different things in your app and see what's causing latency problems. But as you'll notice here, it breaks these things apart by endpoint. And for GraphQL, we had one endpoint. So the problem that we ran into is that sometimes our GraphQL endpoint returned things super quick, 100 milliseconds, no problem. And sometimes it was taking a few seconds to resolve. And we didn't have good insight into what was the problem. And there are some things that you can do to help with this with GraphQL, which I'll get to a little bit later. But adding to this was this idea of GraphQL aliases. So remember at the beginning when I said you can ask for as much data as you want, and that's really great and really flexible, but it can also cause problems because if you ask for way too much data, you can get way too much data back, right? And it will slow your network request down. So GraphQL aliases allow you to make multiple requests for information in a single network request. So here you can see we have this query get users, and we're calling all the users that have a role of admin and all of the users that have a role of accountant. And I can show you in our graphical as well that if I want to, I can make a request to get hello and error, both of our queries at the same time, and click enter. And then you can see that under data, hello came back great, error did not return anything since it threw an error, and we get our normal error back as well. So this is, again, part of the reason why this would be a 200 status response, so that you can get back some information and not others. But with these aliases, like I said, if you ask for a ton of information, then you can get a ton of information back. Great. The last thing that I'll talk about is a lack of convention with GraphQL, especially around mutations. So GraphQL, I think, is great for querying information, getting back what you need. But mutations are a little bit trickier. So again, mutations are anytime that you're creating, updating, or deleting anything in the database, making updates to the data. And you can name them whatever you want. So I named this add stuff, which is very descriptive. But you could name this create, you could name this update, you could name this delete, and you could follow your own conventions, but it's not quite as clear as having those RESTful standards and types of network requests to fall back on. Another thing that I ran into was trouble making batch updates. So in this example, this would be kind of what it would look like to make a batch request to add all of these things. And you have to pass in an array, and then you have to ask for an array back. And there just wasn't a lot of documentation about how to do this, even though it's a pretty solved problem in REST APIs. So this was something that was interesting. There is also just a default limit to how long your queries can be, because they're all being passed in as query parameters. And there are also some potential security issues there with having to ask for everything through query params. Okay, so now that we've gone over the reasons that we chose to use GraphQL, all of the great things about it, and some of the drawbacks that we ran into, it was time to make a decision for how we were going to move forward with this API. And there were a couple of possible solutions that we could have done. We could use a REST service for creates and updates, but GraphQL for reads. And we even considered using GraphQL as basically a proxy layer right before our REST API, so that GraphQL, when it was asked for a query, it would hit the REST API and then return the response back to the front end. But that kind of begs the question of what are we gaining from having this extra GraphQL layer? And there wasn't a great answer for what we would be gaining there. We could also put more resources into making our GraphQL API better. So it was clear that we needed more insight into which queries were performing badly. And we could have potentially set up something like an Apollo client, because I think Apollo Studio gives you a lot of insights into which queries are happening and which ones are taking a long time, et cetera. So we could have put effort into that. But in this specific use case, it made more sense to build a REST service for all of the reasons that I listed, especially just given the context of the company, following conventions and allowing other teams to easily consume our services made the most sense for us. So lessons learned from this experience. The lesson is not never use GraphQL for anything, because no technology is perfect. So you really have to ask yourself and your team, what are we trying to solve? And how is this technology helping us solve that problem? And if there's not a clear answer for how the new technology is helping to solve that problem, maybe it's not the best use case for that new technology, and probably a better use case will appear at some point. And the lesson learned too is don't be afraid to try new things. I think it was great that we built this GraphQL API. As I mentioned, it allowed us a lot of flexibility. We didn't have to plan out an entire REST API. We could quickly implement and make new query objects, make new mutations, and get up and running really quickly with our new product. But it's also important to not be afraid to change your mind. So if you're trying something and it's not working and you're pulling up the pros and cons and it makes more sense to switch back to something, that makes a lot of sense too. And in the end, that was what we decided to do. We went back to the safety of the Hobbit hole, back to a REST service, and sunsetted GraphQL in this instance. So thank you so much for listening to this talk, and I think we have some extra time for questions, so we'll pop into the Zoom chat. Thank you.
All right, thanks so much for coming to this talk. We don't have quite as much extra time as I thought we would have, but I'm still happy to hang out for 5 minutes. If anyone has any questions, feel free to put them in the chat or the Q&A. And if not, then thanks again. Great, so just got a question, will I ever try GraphQL again? And definitely, we do use GraphQL at Handshake, the company that I'm at now. I haven't had a chance on my team to use it yet, but I think that there are some great use cases for it. And I think it makes a lot of sense as something that you think of as a little bit closer to the front end than to the back end. So with Handshake, we are using GraphQL to query for results that we're getting from Elasticsearch. So I think it makes a lot of sense there. And I'm always happy to try things again. Just wasn't the right fit for this particular use case. And even if something is the coolest and the coolest new thing, the most hype new thing, doesn't mean it's perfect for everything. Awesome. Got another question about the GraphQL latency issues that my team ran into. And I don't think that those are specific to GraphQL, but rather they were basically, yeah, that's a good question. Sorry, let me just put my thoughts together. But they weren't really specific to GraphQL itself. It was more a problem of trying to get too much data at one time. So making all of those queries to the database in one go, and then just like the sheer volume of JSON that was being returned back to the front end. So as long as people are aware of those constraints and are using GraphQL aliases carefully, then I don't think that you would run into these data problems, and I don't think GraphQL itself is slow. But you just have to make sure that you're using it appropriately, and that you have the insight that you need into what is causing things to be slow when that does happen.
Katie, I'm not sure if you saw this question from Todd or if this is on the same topic, but Todd is asking, can you describe the data source between your resolvers?
Yes, great question. So we had a relational database behind the resolvers, which is probably another reason why this wasn't the most natural fit, because we had a MySQL database that we were hitting from these GraphQL resolvers. So the relational database kind of blended itself better to a RESTful API, and that's a really good point. Okay, seems like that's probably all the questions. Feel free to reach out to me on LinkedIn or Twitter if any other questions occur to you. Would be happy to chat. And thanks so much.